Aloha everyone, welcome to the August 2020 edition of the Hawaii Volcano Watch Report. In this report I will be covering the Mauna Loa Volcano, Kilauea Volcano, and the Halema'uma'u Crater Lake. You may remember in last month's update I talked about changing the frequency and format of the Hawaii Volcano Watch Report. I've been thinking about it quite a bit and I had an idea. What if I did it in a live stream? How would I do it? And what would it be like for the viewers? I figured there was only one way to find out. So here it is, the first live Hawaii Volcano Watch Report for August 2020. After giving it a watch, let me know down in the comments what you think about this format. First up is the Mauna Loa Volcano. On Thursday, August 13th, the Usgs reported that the seismometers on Mauna Loa recorded around 164 earthquakes below a 2.5 in magnitude in the past week. The majority of those quakes occurred at depths of less than 8 kilometers or 5 miles below ground level. GPS systems on Mauna Loa continue to show slow inflation on the summit, consistent with magma supply to the shallow storage system. However, gas concentrations at the summit and sulfur cone monitoring sites are remaining stable, with SO2 measurements recorded below 2 parts per million at both locations. The recorded fumarole temperatures at the summit were 98 degrees Celsius, which is within the normal range, and over at the sulfur cone, temperatures were slightly lower, but still within the average for this location. Webcam views again have not shown any significant changes to the volcano's landscape. These reports always reference the number of earthquakes that have occurred on Mauna Loa Volcano, but I don't usually do a deep dive into that data. However, in this format experiment, I am now going to do just that. Now, I will be reviewing this information in real time here in the live stream, so please be aware that the presentation might not be as polished as the main body of the report. Okay, let's go over to some of the data maps. The first thing we're going to look at is going to be the earthquakes for the last, I think I have it set for the last month. There's been 487, all magnitudes and depths. And as we can see here, located around the Mauna Loa Volcano, the quakes are still located in the general area, which is up at the summit and on the southwest flank, or southwest rift zone location. If we go over to the deformation data, we're going to take a look at the electronic tilt. And this is interesting because if you see these lines, this green one, this is from the MOK raw data 90.0. And it is the radial tilt, and it shows that there is a consistent movement on the summit. But we're also going to go down and look at the what I find to be an interesting little pattern here, and it's this map right here. This is showing us the I forget real quick. Yeah, this is the distance between 2 GPS stations which are located on the opposite sides of the summit Caldera on Mauna Loa. And this is showing basically the distance between them as time goes along. And if we look back here at March 2018 to September 2018 on the map, actually let me zoom in a little bit on that for y'all. We see it kind of flattens right here. This is during the Kilauea eruption of 2018. But after the eruption stopped, we see the trend of the distance or the widening between these GPS monitors up at the Mauna Loa summit, showing a constant uptick in the distance, showing that there is continuous inflation on the summit of Mauna Loa. Okay, let me go back to normal zoom. And that was over a 5-year trend. Now, if we look at the vertical motion here in the past year, we can see again that there is a continuous pattern of rising inflation. In other words, the altitude of the summit or the ground surface there is rising over time, and that is because the magma is filling up the shallow magma chamber. And give me just a minute here. I want to shut off my notifications so we are not disturbed any further. I do apologize. Okay, to continue. So, and here looking at the past 5 years, we pretty much can see the same pattern. And this is what we're looking at. Again, we can see that kind of that flat line right there during the 2018 Kilauea eruption. And then after that, a continuous rise. It's really very interesting because if we look at this one right here, which is the tilt over, okay, this is the tilt over the past month. What I find interesting is we see these peaks and valleys, you know, tilts one way, comes back, tilts back, and it oscillates. It almost looks like a heartbeat, you know, what you would see on a heartbeat monitor, which I find very interesting. It shows that the volcano, at least Mauna Loa, is still very, very alive. And just to give you an idea, this is where the GPS and tilt meters are located up around the summit. And so when we were looking at the one map showing the distance increasing, that is what's basically happening is the distance across the caldera is increasing. That shows inflation, you know, on the summit region. Okay. Nope, sorry, lost my place there. Okay, here we go. Okay, moving on. On Thursday, August 6, 2020, the USGS reports that fewer than 1,100 earthquakes occurred in July, in the July monitoring period for the Kilauea Volcano. That is around 10% lower than in June 2020. Out of the 1,100 quakes in July, only 2 of them were stronger than a magnitude 4. It appears these quakes were associated with the slip along the south flank basal detachment. In July, tilt meters at the summit recorded 16 deflation-inflation events. That indicates an increase in the total number of DI events compared to those that occurred in June. Over at the Middle East Rift Zone, the episode of rift inflation west of Highway 130, signaled by the increased deformation rates in March 2020, have returned to the pre-March trend since the reduced and leveled measurements recorded in May. Looking at the long-term trend of the deformation at the summit of Kilauea and the Middle East Rift Zone indicates continued inflation at those locations. These measurements signal the continuing supply of magma to the shallow storage system of the Kilauea volcano. Taking a quick look at the south flank of the volcano, the GPS stations are still showing the elevated rates of motion towards the ocean. The rates of sulfur dioxide emissions are still low at the summit, which appear to indicate there is no significant shallowing of magma. However, the general belief remains that the Crater Lake water is absorbing some of the gas emissions. USGS states that they are continuing to work on the understanding of that process. Now, over at the lower East Rift Zone and at Pahoa, the sulfur dioxide emission rates also continue to remain below the detection limits. Now, like I did with the Mauna Loa, we are now going to take a more in-depth look at the earthquake and deformation data for Kilauea. Okay, now here on Kilauea, the earthquake information is a little bit more interesting because there's a few things I'm going to talk about. First, let's go to the actual Kilauea summit area and the rift zone, which is what we're looking at here. And we see that the general quakes are kind of centered up around the summit area, which is to be expected. We are seeing inflation there, and there is also still settling from the 2018 Caldera collapse. However, if we look down, we see this chain of earthquakes going down into the upper and middle East Rift Zone. And that's basically this location right here. And then it makes this curve and continues to go on down into what we, of course, know is through Leilani Estates. However, we're not seeing the quakes go all the way down that way, which is good. During the 2018 eruption, we saw the earthquake storms literally travel right down this line and into and past Leilani Estates. But what we're seeing here is the Middle East Rift Zone, which is pretty much Pahoa, and just approaching Highway 130, which is right here. So this is where we're seeing a lot of the inflation, and of course up at the summit and the quake activity. So far, nothing out of the ordinary jumps out. with any of the data. It's pretty standard, especially when Pahoa was erupting. There was constant, quakes in the area, etc. So what we're seeing now is basically a recharge of the shallow magma system, which is absolutely normal after an eruption event. However, now I want to go down to the Pahoa area and the South Flank area, and we can actually see two clusters right here. We have the cluster around Pahoa, and then we have this cluster right here around the would be the southwest rift zone of Kilauea. And if I pull back out, you can see that they're very individualized in their locations. Now, it is believed that the quakes under Pahoa, which is a very normal thing to see, Pahoa has always been a deep quake activity center. Most of these quakes aren't really felt by the residents there. However, it is believed by USGS that this could be the location for the mantle plume, which is the magma source feeding the volcanic islands of the Hawaii system. Now, these quakes right here, though, I don't believe would be magma related. I think these are related to the slippage that's occurring along the south flank of Kilauea. But these are relatively new in their clustering, which means there might be some movement, some extra movement occurring there, but nothing that would be too out of the ordinary. But it is definitely something to keep an eye on. Okay, now let's go over and look at the deformation data. Where was it? There's a couple charts I want to show you. Okay, this one right here, the earthquake rates over the last week. As you can see, they're staying quite steady in the number. This is actually the number of quakes per day over the last week, each blue line. And we see here just on the 16th or the 17th, I'm not sure how to read these little lines I got here, but there was over 50, almost 55 quakes, it looks like, for that time period. So that was our peak for last week. But like I said, this is staying pretty constant in the number that we're receiving on average per day. But what I find interesting actually is this little chart here. This is the graph showing the depth of these quakes. And we can see the majority of them here at the top is very shallow. And that we believe is the filling of the shallow magma system. But then we have this line very deep here, which is 30 plus kilometers deep in or excuse me, the quakes centers are, that is. And I find it interesting that we have two distinct lines like that. We have a very shallow pattern up here, and then we have this very deep, less number, but still very distinct in its depth, very consistent. I'm not quite sure what to make out of that, but I do find it very interesting that I'll just leave that. I don't really know what to think about it, but it is definitely very interesting. But I will be looking into that further. Okay. Here is, for the past week, the tilt meters, and as we see, we have that same pattern that we're seeing on Mauna Loa, the downs and the ups. This shows, basically continual injections of magma into the shallow system. And these, when you hear me refer to data points, when doing the reports and things like that, this is pretty much what I'm talking about. All these signals, look at these earthquakes. But this is for 5 years. Don't freak out, everybody. I want to go to the 5-year chart because here we can see the depths. We see that same kind of striation pattern right there. And I got to learn a little bit more about why that pattern exists. But what I wanted to go and show y'all, if I can find it real quick. Yes, these are the two charts right here. Okay, looking at this one, what we're seeing here is in this drop right here, this is the period in which the 2018 or the 2018 eruptions had occurred. And this is basically showing how the inflation on the summit basically dropped as the lava flowed. And then after the while the eruption was over, we saw almost immediately refilling starting to occur. And this is basically since September 2018, when the eruption ended. This is basically how much of an increase has occurred in summit inflation, which looks to be about 0.75 meters. So that's pretty significant in the increase. This little map right here, this is at Pu'u'o. What we're looking at here is when the collapse happened at Pu'u'o, and the inflation then, of course, started. And it seems to have a greater inflation there at Pu'u'o. And if you remember looking at, let me zoom out. And of course, if we go back, and let me find what I'm looking for. There it is. If we go back to the earthquakes, you know, Pu'u'o is right here. So this area obviously is going through an inflationary, you know, this is when I say the DI events, deflation, inflation events. Basically what that is the deflation is when basically the mountain deflates, or the ground surface level lowers in altitude, respectively compared to where it was before. And of course, an inflation is just the opposite of that. It's the rising of the surface as magma fills the chambers underground. So basically the island is like a giant balloon that's being inflated and deflated, you know, and we see that in of course, the deformation data, which is basically this right here. This is for the last month. And that's what these lines are indicating. The upticks are inflation and the downticks are deflation. And it's like a regular heartbeat. And as you notice, this blue line is going up, up, up in the graph. And that's because there's more inflation occurring than deflation occurring. So we inflate a little higher, deflate a little lower. Then the next cycle we go up a little bit. And then, you know, the down cycle is a little less, and blah, blah, blah. Or excuse me, so forth and so on. Okay. What else was there? I think there was one more little thing. No, I believe that was pretty much it for that. Just looking over everything real quick. Okay. Well, that looks like it will take care of all the data for Kilauea. Okay, now for the part that I'm really excited about. I really love looking at the Halema'uma'u Crater Lake. So we're going to go into that portion. Okay, in the final segment of the report, I'm going to take you back up to the summit of Kilauea. And we're going to take a look at the Halema'uma'u Crater Lake. Now, on July 31st, the crater lake's depth was measured. Measurement was approximately 135 feet or 41 meters deep. The lake water itself also continues to be dynamic with the color variations in the boundary lines. In July, the USGS released some great photos of the crater lake. I'd like to show you some of those now. This first photo, taken on July 21st, USGS took 3 photos of the lake. The first one was taken at 8:45 a.m., which is the one you're looking at now. And you can see the morning sunlight reflecting off the water, which is the bright radiance you see on the water surface. The next image was taken at 10:15 a.m. In this photo, you can see the ripples on the water surface reflecting the morning sunlight, and which I think is just beautiful. I love how it looks like it's just covered in diamonds. In the third photo, taken at 11:20 a.m., the reflections of sunlight on the surface of the water have become minimized. That permits us to see the authentic colors of the lake. What we see here has become customary for the lake, which is the shades of brown and tan colors we see, and of course that sharp color boundary traversing across the water body. Here is an interesting photo of an HVO geologist, top right corner of the image. He is collecting GPS data on the western rim of the summit caldera. The person is standing on a thick series of tephra deposits that formed during explosive eruptions on the Kilauea summit. These eruptions occurred between 1500 CE and the early 19th century. What is truly interesting is these layers are deposits that cap a much thicker series of lava flows. You can see them here in the bottom left of the photo, and they formed from eruptions dating before 1500 CE. In recent years, research has revealed that Kilauea Summit oscillates between explosive and non-explosive periods, with the non-explosive periods ruled by lava flows. That makes you want to ask the question, when is the next explosive period? Moving on to July 24th, USGS posted this very cool comparison photo. The left image, which was taken on August 2nd, 2019, is of the crater lake when it was just a baby. It was a fantastic small green pond that was only about 6 feet or 2 meters deep. Fast forwarding to almost a year later, the image on the right, taken on July 21st, 2020, shows our baby pond has grown up to be a mesmerizing lake of about 130 feet or 40 meters deep. Now, as we watch this time lapse of the crater lake form from baby to adult, I'd like to note that on Saturday, July 25th, 2020, was the first anniversary of the discovery of the newly formed crater lake. In the last year, the lake has grown to a size of more than 885 feet long and 430 feet wide, or 270 meters long and 131 meters wide. The surface area is over 6 acres or 2.5 hectares, and the depth is over 130 feet or 40 meters deep. It is estimated to have a volume of around 480,000 cubic meters, or 125 million gallons of water. That is equal to nearly 200 Olympic-sized swimming pools. I would also like to point out that the movement of the surrounding ground surface is not real. It is an illusion created by the slightly different camera angles on different days. Now, real quick, I just want to mention, if you have any questions about the Hawaii volcanoes or anything in this report, get them ready and post them in the live chat. I will be opening the Q&A part of this new format at the end of the report. Now, this photo that the USGS captured on July 28th is just absolutely beautiful. We get to see some of the incredible green that we witnessed when the lake was just a young pond. What is intriguing about the green patches is they tend to be slightly warmer than the rest of the water. They also appear to be the areas where new water is entering the lake. I wonder if the periodic appearances of these areas are the result of surges in the volume of water entering the lake. If so, could these surges occur from rainfall water seeping down into the water table that supplies the lake? I do believe these to be two excellent questions. Maybe we'll know the answers to them sometime in the future. Until then, we will keep watching. Okay, now for another time lapse that was posted on July 31st. This time lapse covers about 30 minutes and illustrates the spectacular dynamic nature of the water. You can also see steam from the surfaces steadily shifting in the wind currents, and the migrating color boundaries seemingly show the water circulation. Now, before I continue, I do also want to show you this, which is the same video, but this time I have modified it with false color processing to help accent the hypnotic movement of the water. If you remember in a previous photo showing the green areas of water influx, you can see that looking in the same locations, it would appear that they are the areas creating the motion in the lake water as well. Okay, this next photo, in my sincere opinion, this photo that was taken on August 7th, 2020 is the perfect picture to wrap up the Crater Lake segment of the Hawaii Volcano Watch Report. The Kilauea Summit webcam captured this magnificent rainbow over the crater lake as a light mist moved across the caldera. I wonder which end has the pot of gold. Okay, now that will wrap up the Hawaii Volcano Watch Report, but don't click away yet. There is still the Q&A portion of the video coming up in just a moment. First, I want to remind you, to get notifications of new reports, you must be subscribed and have all notifications turned on. Also, to help keep these reports coming, your channel support is needed. There are many ways that you can do that. You can purchase super chats during live chat, which I noticed one came in from Hisense Chris. Thank you very much for that. You can purchase the super chats during live videos, or you can pick up the fantastic merch I have available. Links there on the screen and also in the description. Clicking that like button and sharing is also a perfect way to show your support too. Finally, if you prefer, you can also make a donation using the link available in the description below. Now, if you will please stand by for just a few moments while I look over the live chat for any questions, I would appreciate it. Okay, thank you for your patience. I do appreciate that. A couple good questions did come in. First, I'm going to start with one question that was posted on the comments of one of the previous update reports, I believe it was, and it was asking about the risk to Hilo from Mauna Loa eruption. So, what we're going to do is we're going to take a look at that and see what kind of risk there would be. So we're going to go back to the earthquake screen. Okay, as you can see, there are the earthquakes mostly up around the summit and caldera area. There are also some flank eruptions or flank earthquakes as well. However, looking at where the earthquakes seem to be remaining, I would say at this point, if there is going to be an eruption at Mauna Loa, it's probably going to be more of a summit eruption versus a fault eruption. But that's no guarantee. There's really no way to predict exactly what a volcano will do at any given time. However, for it to be a risk to the Hilo area, the eruption would have to occur on the northeast or east area of the volcano. Now, we did have one finger some years ago. I think it was in 1954. I'm not quite sure about that. I'm sure some of my other some of the subscribers in the chat may know the exact date of that one. But there was a finger of lava, which, if I'm correct, it's going to be these right here, that headed towards Hilo and actually threatened Hilo for some time. So those eruptions came from the end of the northeast rift zone area. So that's where the eruptions would have to be to threaten Hilo. Now over here where they are now, if they come from any of this area, then it's going to be basically the Kona side of the island that it would be more at risk. And we do have evidences where lava has flowed to the ocean there as well. You can see right here some of these fingers made it all the way down to the ocean. I'm not sure what the dates are on those, of course. So that's pretty much the risk for a Mauna Loa eruption. If Mauna Loa was to erupt here on the southeast or more eastern area, Kilauea is actually going to protect the Puna area or the eastern tip of the island from that eruption. However, the Pahoa and Nahaleu areas and stuff could potentially be at risk, and including South Point as well. But again, until an eruption actually occurs, we're really not going to know who's at risk. So that, I hope, answers that question. Okay, let's see. Chris, or Hisense Chris, has asked, question, landslides in some of the photos as the water rises. Is that caused by ground saturation as the water rises, or shallow earthquakes at the summit causing minor collapses of the sides? That's a very good question, Hisense. And I think the answer to that is yes and yes. It's both of them. Obviously, we know minor quakes, and as you can see, we're getting definite quakes let me actually, no, you can't see, but now you can. Yes, as you can see, we are definitely getting quakes, you know, up around the summit and in the caldera itself. So those are definitely going to cause rainfalls or rock slides, and of course the rain is going to, you know, help basically give a shallow subsurface water layer that's seeping down, and that will act as kind of you know, a friction releaser as well. So yes, it's a combination of both, you know, entering water, rain, and of course earthquakes. Sophia is asking, Charles, is the lake still growing? Sophia, yes, it is still growing. We are seeing the speed at which it is expanding and deepening is slower because of the shape of the basin, which is that of an inverted cone. So now as the water rises, you know, and more water enters, it's going to look like it's rising slower and spreading out slower, even though the same amount of water or volume of water is still entering the lake at a relative consistent rate. So yes, it is still growing, and if I remember correctly, USGS says that if nothing stops the process, that it should eventually equalize with the height of the underground aquifer, you know, the water table that's apparently feeding this lake. It should equalize with the same, you know, height as it over time, which could be extremely deep, because the bottom of the caldera pit, if I remember correctly, is lower than the bottom of this water table. So we're going to have to wait and see exactly what all comes from that. Okay, Lynn is asking, Charles, what is tilting? Basically, radial tilting is where, well, it sounds just like that. Stick a stick in the ground and push it slightly over a little bit, and that's a tilt. And when they say radial tilting, it's because they put it on an XYZ axis, basically. So any deviation off of that axis would be considered tilt. So in this case, a stick stuck in the ground would be pointing up on the z-axis, because x and y is two-dimensional, and z gives us our altitude or depth. So basically, that's what tilting is. It's where a stationary feature has not moved in ground location, but it has tilted in one direction or another. And so basically, think of it like this: put two dots, or glue two little sticks to a balloon, you know, right next to each other so they're parallel. And when you blow that balloon up, the surface area between them will stretch, and you will get a tilting on those little pegs. And the distance between the tilt of those pegs shows a certain distance or expansion in inflation. Like when I was talking about the distance between the GPS units on Mauna Loa earlier in the report, that's basically what they're looking at, is the tilting there of the land being pressed upward, and you know, the surface begins to tilt, you know, and in this particular case the two GPSs are tilting in opposite directions. I hope that answers the question. Austin, the good question. He's wondering, I'm wondering what level of activity is the worst this system has to offer. Ancient Hawaiian lore associates the crater lake with explosive eruptive activity, right? There is some stories that indicate you know, explosive activity there. There's also some stories that seem to indicate that there may have been a lake there in the previous past, but USGS hasn't been able to confirm that, and some of these stories, you know, are not your most common Hawaii lore, but they're interesting. And I was reading something from USGS about a week ago dealing with just that, them looking for evidence of past crater lakes in the Hawaiian stories, and they found some stories that may indicate similar situations, the caldera collapse, etc., but no actual account of water forming afterwards. So it's a very good question, and it's something to look into more, which I might do a video specifically about that later on. Let's see, any other questions? Okay, Hisense asking another question. In the island map, the lower section shows what seems to be fractures. Are those land separations or previous fissure lines? I'm not sure which island map you're talking about. It's got to be this one. Okay, and if you're talking about these fractures, it's just a trick of light. These are actually large drop-offs. These are the polys in Hawaii Volcanoes National Park. These, of course, are where the fault lines is for the Kilauea Volcano. The Mauna Loa Volcano's fault lines pretty much run right down through here, going into South Point. So I'm not quite sure, Hisense, what you're asking there exactly. Excuse me. Okay, I'm going back over. Todd is asking, Charles, is the lake still warm enough to cook hot dogs? Yes. I think one of the last temperatures I saw showed that it had increased a little bit. So we're looking at 165 degrees Fahrenheit, I believe it was. So it's not quite boiling, but it is something that would severely burn you. It would definitely cook an egg, a hot dog, pretty much anything that would cook over low heat. Okay, and Mark, yes, I am in Hawaii. I don't monitor all the earthquakes, but a 6.8 earthquake is a big one, and big ones usually signify can signify other activity. So I would suggest that you check in more on your local information there, and that would be a better follow-up for you. David Zines is asking, how toxic is the lake? Well, you know, David, that is a very good question. I wouldn't drink it. I don't think fish can survive in it. One, it's too hot pretty much for anything other than extremophile life, I think, at this point. Also, it is basically a chemical cocktail soup. We know there's sulfur in it. We know there's iron in it. I'm sure there's CO2 and carbon monoxide. Pretty much all the gases coming out of the volcano are probably being absorbed into the water. So, yeah, I would say that the lake is toxic. Just how toxic, I guess, is a matter of perspective. I think any toxicity is too toxic. But yeah, this is not a place or that's friendly to life on any level. And it's very hot down there, of course. Dale is asking, have they determined exactly where the water source is that is feeding the lake? Yes, Dale, it's not an absolute positive thing. They're using their educated knowledge and scientific data. It is believed that the majority of the water is coming from the underground water reservoir that is perched on top of the Kilauea summit. But we also have, through chemical analysis from drone or water samples that was taken by drone, that the isotopes in the water show that it is also rainwater. So at this point, it is believed that it is a combination between the water reservoir perched on top of the summit, and some rainwater is definitely contributing as well. Todd, I guess, is asking, does the water in the lake pose a risk for explosive eruptions? Not quite how he formed the question, but that's the way I'm going to interpret it. Yes, it definitely poses a risk. Anytime you mix lava with water, you're going to have explosions. So the question is, and I've talked about this in a previous video, but I will also I will also talk about it again because I think it's something important that people need to understand, is that this crater lake is a unique phenomena. It's not something we have seen in the written history, modern history of it being in the crater lake. So exactly how it's going to interact with lava is only educated guesses at this point. But we have a couple scenarios that could occur. One, when magma starts returning or shallowing out of the system, if it does it slowly and quietly, then we should expect the water to just boil off over a short period of time, be gone, and then of course perhaps an eruption. If the magma rises back up quickly, well, then that's a different story, because that doesn't give enough time for the water to boil off. So there could be potential interactions, some steam explosions, etc. Now, some other potential possibilities is that as the magma begins to rise, it could trigger some major earthquakes. And these earthquakes could basically open up a hole at the bottom of the lake, which would allow the water to drain out very rapidly down into basically into the magma that would be shallowing. And of course, that would be a violent reaction and cause explosive reactions as well. So there are a couple different variations, and those are the three more plausible ones. So it's a wait and see thing. Okay, Hisense is asking, do you think Luihi will be a separate island or merge with the big island? That is a very, very good question. And I would say, because if you look at the other islands, there are channels, like we can see here a little bit of the water. So we can see this is kind of the foundation of the Hawaii island, going through here, and this is basically stuff that was above water at some point in the past, but has finally eroded away like the islands do over time. And there's a small channel here. And we of course got a volcano. I forget the name of it right here on the tip of the island, and of course we've got the volcano here. So you see the volcanoes really aren't that far apart. And if we look on the big island, we've got the Mauna Kea, we've got Mauna Loa, Kilauea, and then down here Luihi. So as you can see, they're not that far apart. And if I pull out so we can see a little bit of the underwater topography here in the blue, you can see right here is the summit peak, but there's no flat ocean flats between Luihi and the big island. There's some landmass underwater there. So as this erupts and builds up, I suspect at some point there might be land bridges, if not a solid plain connecting the two. But I don't think it will last long. But that's just my guess. I really don't know. Dale, I don't think I understand your question there. Any water returning to the crater filled with lava? We currently don't have any craters filled with lava. Thank you, Sophia. That was the Kohala volcano I was talking about. Todd's asking, Charles, can the crater handle that much water? I don't know. I don't really think anyone knows what the crater can handle water-wise. We don't have any, past observations and data to help answer those questions. So this is basically a new experience for all of us. Dr. Mark Caro is asking, Charles, can you outline the Kilauea summit showing the rift and flow zones? I can give you a general idea. I don't have anything prepared to show exactly, but we'll zoom in here a little bit. Okay. This area right here is the Halema'uma'u Crater, or Kilauea Summit Caldera. And there are two main rift zones. We have the East Rift Zone, which starts out right here where you see these line of quakes. And then we have the South West Rift Zone, which goes out this way. So we'll start with the east one. The east drift zone comes right through here, and I'll zoom in, you can see all these little pot marks here in the map. These are craters, and this is the Chain of Craters Road in Hawaii's Volcanoes National Park. And the reason why it's called Chain of Craters Road is because it goes down through a chain of craters. However, when we get down here to Mauna Ulu, the rift zone actually takes an easterly turn, and it travels pretty much parallel to the southeast coast of the Big Island, and runs through here all the way up to Pu'u'o, which is this feature right here. This is Pu'u'o crater, and this was the crater that was filled with lava for over, I think it was 36 years, the longest erupting period that we have in written history, until the 2018 eruption. It is now has no lava, but it is still producing a little bit of steam and gas emissions. All right, this rift zone then continues and takes a little bit more of a northerly turn and flows right up through here, straight into Leilani Estates and past. And in actuality, I've been looking at some of the topographical maps. It does continue to extend out through Kapoho and into the ocean as well. So that's the east rift zone. This is the lower east rift zone. Is everything considered on the east side of Highway 130? That's considered the lower east rift zone. The stuff between Highway 130 and Pu'u'o area up to, I believe, almost Mauna Loa is considered the middle east rift zone. And of course, between the summit and Mauna Ulu and Pu'u'o is the upper east rift zone. Now, the southern east rift zone is more straightforward. It basically travels right down through this line where you see all these little lava flows. This is the fissure line area going right down through here. And it travels right down through the southern flank and, of course, out into the ocean. And in my topographical maps, it almost looks like it makes a turn and connects into one of the Luihi's northern rift zone area as well. Not real sure about that. Oops, sorry, I hit the mic by accident. Okay. Danny, no, there is currently no eruptive activity on the Big Island of Hawaii. There is no active lava anywhere to be seen, and that is a good thing for now, but that just means we're waiting for the next eruption. And that can happen tomorrow, or that can happen 30, 50 years from now. There's no way to tell for sure at this point. Data shows that the volcano is recharging itself, but that can be a slow process. Okay, I'm just going to quickly go back over the chat, see if there's any more questions. Okay, I do believe we've covered most of the questions. I'm not seeing anything new. Some great questions. I do appreciate that. A lot of great information I was able to provide. At least I hope it was. So, that, I think, let me just double check. Yeah, okay. Charlie Ireland is asking, Mauna Loa is starting to reactivate, right? Well, the alert level was raised shortly after the 2018 eruption because of major uptick in inflation and quake activity there. So it is currently recharging. We have no indication of any pending eruption coming at this time, so things are still quiet and calm. But the potential for a Mauna Loa eruption is higher than what it was before the 2018 eruption. Well, I think that covers it for this experimental version of the Hawaii Volcano Watch Report. Remember to let me know down in the comments what you think, they're down below, about this format. And mahalo for watching, and have an amazing morning, afternoon, or evening.